because it's only the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system. It's interstellar, it's between suns.
When 3I Atlas finally got close to the sun, scientists were excited that it would finally give them answers they've been seeking.
NASA scientists first spotting 3I Atlas in July, just a tiny speck of light sailing through a sea of stars, a mind-bogglingly rare visitor from outside our solar system.
But instead, it went dark, dropping out of major observation networks. And then just when most teams had assumed the event was over, it came back. But what returned isn't the same object they thought they understood. 3I Atlas reappeared with a terrifying new structure, and with activity no one can fully explain. Now astronomers are terrified they're witnessing something entirely new, something that is getting even harder to explain. It didn't burn up. On October 13th, 3I Atlas reached Perihelion. For an object hurtling from deep interstellar space, this is the moment of highest heat and maximum radiation pressure.
So a strange voice from deep space, a mysterious object named the 3I Atlas, has just sent a signal aimed directly at planet Earth.
Astronomers expected activity to spike and then drop, just as it had for other known comets. Instead, what followed was quiet. The object did not erupt into a fireball. There was no sign of disintegration. For almost 9 full days after perihelion, 3I Atlas remained dimmer than expected. Surface jets that had been seen in August had weakened. By the third week of October, many observatories began to shift focus to other targets. It was assumed the event had passed. The object had peaked and would now recede. Then, without warning, everything changed.
And it's only the third object ever confirmed to have come from interstellar space.
On October 22nd, observatories across Europe and Asia began detecting a rise in reflected sunlight from the object. The change was not subtle. Between October 22nd and October 24th, the object's brightness increased by a factor of 6. The light curve spike was sharp, narrow, and did not follow the known thermal decay profiles for post-perihelion comets. The first thought was fragmentation. If the nucleus had broken apart, multiple surfaces would reflect more light, but no fragments were observed. It was still a single object. The shape had not changed, but the energy signature had. By October 25th, the comet's coma had expanded by over 30%. Multiple observatories reported faint new emissions that did not match the earlier pre-perihelion spectrum.
A comet that shouldn't even exist has lost its tail, defied physics and grown mysteriously brighter when it should have become dull.
At first, these were dismissed as noise artifacts, but repeated confirmation across several instruments, including Issei's optical ground station and Japan's Subaru telescope, eliminated that theory. The data showed that 3I Atlas was gaining energy. That raised a serious problem. According to known physics, solar heating peaks at perihelion and then drops as the object moves away. The surface cools, ice sublimation slows, dust output declines. But the emissions from 3I Atlas were moving in the opposite direction. The brightness was increasing even as solar exposure was decreasing. One possible explanation was the sudden release of buried volatiles, materials like carbon monoxide or methane trapped under the surface that sublimate later than surface ice. But those signatures usually come with distinct absorption lines in infrared. Here, the spectrograph showed no such lines.
The comet's path will take it past even more of our robotic explorers.
Whatever was being released was not standard cometary gas. More unusual was the location of the emissions. Instead of being evenly distributed across the sun-facing side, the brightening appeared to originate from a concentrated point near the object's rotational axis. That is not typical behavior for natural outgassing, which tends to spread based on heat distribution. In plain terms, it was as if the object had reactivated from a fixed point. Radio telescopes also began picking up faint thermal anomalies around this same region, too hot to be explained by passive solar heating alone. The surface temperature in this band was nearly 20 Kelvin above the surrounding areas, despite receiving the same solar input. The object's trajectory also began to show minor deviations. These were not large enough to indicate an entirely new orbit, but they were measurable. Several orbital modelers at the Jet Propulsion Laboratory noted that the object's projected path now required adjustment beyond standard gravitational influences. This, too, was strange. When comets accelerate unexpectedly, it is usually due to strong surface outgassing. Jet forces act like microthrusters, slightly pushing the object in new directions. But here, no such jets had been observed during the period of deviation. 3I Atlas still looked like a comet, an elongated shape with a coma and tail, moving on a curved inbound to outbound trajectory. But nothing about its post-perihelion behavior matched the textbook definition. 3. I Atlas didn't vaporize at perihelion. Its surface brightened when it should have dimmed. Its coma expanded when it should have collapsed. Its motion shifted when it should have stabilized. And in the days after its closest approach to the Sun, it didn't die down. Now, the rest of the world is now trying to understand what exactly just came alive. Signals, silence, and the missing hours. At first, the spike in brightness was strange, but the silence that followed, that was worse. By late October, astronomers had locked their attention on 3Y Atlas.
So on October 3rd, 3I Atlas will pass within 29 million kilometers.
Something had clearly changed. But just as the global effort to monitor it ramped up, something else happened. Something far harder to explain. For a period of nearly 3 hours, no telescope was able to capture a consistent image of the object. But during that window, its exact position became difficult to pin down. Telescopes tracking its movement reported inconsistencies. Not huge ones, just enough to confuse image alignment and blur exposure frames. For radio telescopes, the signal-to-noise ratio dropped to nearly unusable levels. The result was a complete blackout. Most of the time, gaps like this are easy to explain. But this wasn't that. These observations were taken by different systems, spread across Asia, Europe, and North America. They didn't all fail at once. Instead, each one reported strange calibration issues, but only when pointed at that part of the sky. The surrounding fields of view were fine. This triggered concern. The Gaia satellite, which maps star positions with extreme precision, showed jitter in its positional log. Not a full failure, just enough distortion to throw off its processing.
And it's only the third object ever confirmed to have come from interstellar space.
But the moment the field moved away from 3I Atlas, everything returned to normal. The theories came fast. One camp believed it was a dust cloud, a short-lived burst of fine material that created optical distortion that could interfere with imaging. Maybe the object passed through a region of self-created debris, but this theory had a flaw. There was no debris cloud detected before or after, no change in tail shape, no sudden spike in mass shedding. Another theory focused on magnetic interference. Could the object have emitted a brief magnetic pulse, something strong enough to distort incoming signals? This was hard to test, but some spectrographic data showed transient line broadening during the blackout window. That can happen under strong magnetic activity. Still, the field strength needed for that kind of interference would be massive, far beyond anything comets are known to produce. The most conservative explanation was simply rotation. A tumbling object could present a different surface profile. If that profile had a different albedo, it might reflect less light for a short period.
What you're seeing here is the glow of light around the object from scattering sunlight.
But that wouldn't affect radio returns, and it wouldn't explain the weird drift reports from multiple tracking stations, which left one final question. What actually happened in those missing hours? The object was still there, but it wasn't behaving the same. Its motion, reflectivity, and possibly even its surrounding space environment had changed, just briefly. This would normally be discarded. Space is noisy. But what caught their attention was timing. That bump occurred at 3:27 UTC, right in the middle of the blackout period, and it hasn't been repeated since. The team didn't publish a formal paper, but their notes were quietly shared with colleagues. One of those colleagues leaked part of the log to a public forum 2 days later. The entry was simple. Band noise rise at Atlas vector, 42 seconds, flat, no source match, possibly instrumental, possibly not. So now the puzzle had a new piece. An unexplained object from beyond the solar system. A sudden reactivation after perihelion. A telemetry void lasting nearly 3 hours. and a single wide-spectrum anomaly detected during that same void. Separately, each of these could be chalked up to nature, to randomness, but together they hint at a pattern no one fully understands.
NASA were to greenlight a mission, what are the measurements or data that you would need returned?
NASA declined to issue any public statements about the blackout. ESA mentioned tracking inconsistencies in a weekly update, but provided no further comment. Independent observers continued publishing data, but no consensus has formed. And yet, behind the silence, something is clear. There was a moment, a short, eerie window when 3I Atlas did something we weren't ready for. It didn't vanish. It didn't explode. It simply became harder to see, harder to measure, harder to explain. And in that gap, in those lost hours, the scariest question isn't what was missed. It's whether it was hiding. Comet or construct? It has a tail. That should end the debate, right? Wrong. 3I Atlas is shedding material like a comet, but the way it's doing it is where the story starts to unravel. Let's start with the basics. Real comets, natural ones, eject gas and dust when solar radiation hits their icy surfaces. That's what forms a coma and eventually a tail. This process is messy but predictable. The jets spray out in all directions, creating a curved, flowing structure. Think of it like steam rising off a boiling pot. Chaotic, scattered, natural. Normally, jet asymmetry in comets comes from spinning. A rotating comet can appear to fire jets from one side at a time as it tumbles. But 3I Atlas shows a strange kind of rotation, a specific axis with consistent orientation even as it moves through space. That's not how nature usually works. The next red flag was albedo, the way the object reflects sunlight. Most comets have a very low albedo. They're dark, charcoal-like, absorbing most light. But as 3I Atlas got closer to the sun, its brightness increased more than expected. That can happen naturally. But here's the twist. Its spectrum didn't change the way cometary spectra usually do. Typically, as volatile compounds heat up and sublimate, we see spikes in known elements: water, carbon monoxide, methane, ammonia. But the spectrograms didn't show those spikes at expected levels. In fact, one peak showed a strange flatness around the 37 gigahertz range, right where you'd expect more water lines. One theory is that the object's surface contains metals. Not just rocks, metals like nickel, iron, and cobalt. That would reflect light differently. And in fact, researchers at the SETI Institute quietly noted elevated nickel signatures in 2 observation sessions. Nickel isn't rare in the universe, but high concentrations is unusual for a comet. It's more typical in asteroid cores or processed material. You don't find that much nickel on the surface of icy interstellar objects, unless the surface isn't natural, unless it's engineered. That's where the light sail theory circles back in. Avi Loeb's hypothesis wasn't just that 3I Atlas could be artificial. It was that its surface might be ultra-thin, flat, and reflective, like a solar sail.
3I Atlas that was discovered back on July 1st, 2025, this year, and looked rather anomalous. The object is quite large, and it's also aligned in its path with a plane of the planets around the sun.
If that's true, you wouldn't expect normal comet behavior. You'd expect exactly what we're seeing now. Sharp reflectivity, unusual composition, directed jets that don't match random outgassing, and acceleration without visible propulsion. Let's talk about that last one. 3I Atlas has shown signs of increasing speed. Slight, but measurable. It doesn't match the expected deceleration of a natural body slingshotting around the sun. Most comets slow down a bit as they round perihelion and move outward. But 3I Atlas maintained its velocity and might have gained a little. NASA's JPL databases quietly updated its projected outbound trajectory in early November. No press release, no big announcement, just a small vector shift in the database. But amateur astronomers noticed. And the new numbers suggest it's moving about 2% faster than before perihelion. 2% doesn't sound like much, until you remember this object is over 11 kilometers wide. To increase velocity at that size in that short time without visible mass ejection or thrust, that's not something we understand yet. Could it be a light sail? If photons are being absorbed and redirected by a structured surface, then yes. It could be accelerating just from solar pressure. That would mean design, not chance. So what do we have? A tail that doesn't behave like a tail. Jets that fire like engines. Composition that includes refined metals. rotation that resembles attitude control, brightness that doesn't match known chemistry, and a path that hints at propulsion. Add those up. One by one, they could be written off. Comets are unpredictable. Space is weird. But together, they paint a different kind of picture. One where the object isn't just passing through. One where it's operating, watching, or maybe maneuvering. This isn't wild speculation. These are real anomalies, recorded by respected institutions, confirmed by peer datasets. And yet no one has an answer. NASA won't say more. ESA has gone quiet. And even the Galileo project has offered only cautious statements. But if what we're seeing isn't natural, then we're not just tracking a visitor, we're being observed. And that leads to a final possibility, a terrifying one. What if 3I Atlas isn't here by accident? What if this is the first controlled interstellar object we've ever detected? One that's not just built, but aimed. The silence after perihelion. 3. Atlas should have sailed past the sun and lit up the sky. That's what comets do. They get closer to the sun, they heat up, and they erupt. Outgassing increases, tails grow longer, and every telescope points up to catch the show. But this one went very quiet. In the days leading up to perihelion, the point where 3I Atlas passed closest to the sun, activity was ramping up.
When we look at the 3I Atlas after it goes out of hiding behind the sun, and that should happen within a week or two, if it's a natural comet, we should really see a very bright.
Observatories across Europe, Asia, and South America locked in. And then it stopped. For nearly 3 hours, no instruments were able to return consistent readings. 3 hours of silence. And when the object reappeared on the other side of the sun, it was different. The rotation and trajectory had shifted slightly, just enough to raise eyebrows. And the light signature had suddenly become brighter and sharper, like something had activated or unfolded. But the scariest part wasn't what it did. It was what we missed. We don't have eyes on that part of the sky during perihelion. The glare of the sun washes out most optical instruments. Space telescopes like SOHO or Stereo can catch glimpses, but they're not designed for precision tracking of fast-moving, small objects from deep space. So for nearly 3 hours, we had no confirmed telemetry, and the object came out the other side moving faster. Now that doesn't mean the object is artificial, but it does mean one thing. We're not in control. We lost sight of a giant, fast-moving body for hours, and when it returned, it wasn't behaving the way it left. Before perihelion, 3Y Atlas was moving at roughly 156,000 kilometers per hour, give or take. After reappearance, analysis from the ESA's solar orbiter suggested that the velocity had increased by up to 3%. That sounds small, until you remember how fast it already was. A 3% jump at that speed is like slamming a race car into a turbo boost mid-lap, except no one saw the foot hit the pedal. And this isn't a racetrack. It's interstellar space. So how does an object do that? What changed? And why did it happen while our eyes were shut? Some believe the sun's radiation simply intensified outgassing, nothing strange. Others, like Avi Loeb's Galileo team, aren't so sure. They point to asymmetric acceleration, like something chose which way to push. That's what breaks the confidence of traditional models, because randomness can be explained. Chaos is part of nature. But precision? That raises a different kind of question. And if you're wondering why this moment, the perihelion blackout, is terrifying to scientists, here's why. It exposed the limits of everything we've built. Billions of dollars in telescopes, hundreds of satellites, dozens of observatories. And still we had a blackout. Still we were blind. And when vision returned, the object had changed, not being ready. The fear isn't that 3I Atlas is something artificial. The fear is that if it was, we'd never know, because we weren't watching when it mattered. If 3I Atlas was a spacecraft, that's what we'd call it. But because we assume it's not, we're struggling to explain what happened in the blackout. The truth is, we don't know. All we know is that for 3 hours, the most watched object in space went off the grid. And when it came back, it was not the same. That's why this isn't just another comet. That's why the silence matters. Because if one day we do confirm something artificial, the next question will be, when did it activate? And if that answer is, during the blackout, then this whole story won't be about discovery. It'll be about the moment we blinked and missed everything. What this changes forever. The old explanations don't work anymore. We're past the stage of, well, maybe it's just dust, because that dust should have burned off already. We're past, maybe it's just a frozen ball of rock. Then why did it survive perihelion while smaller objects disintegrated? Why is it gaining speed instead of slowing down? Astronomers are not saying it's aliens on the record, but off the record more and more are starting to ask the same question. The telescopes we have today are sharper than anything we've ever had, but they weren't designed to catch fast-moving, non-reflective objects moving at impossible angles. And this leads to something no one wants to admit. Our technology isn't ready, not for objects like this or for events like this. If this is a scout, a relic, or something more advanced, it will pass us by, and we'll be left with blurry images and too many questions. If we're lucky, it's harmless. If we're not, we won't be able to stop it anyway.